So again, welcome to Introduction to Data Mining. This is our first lectures. This course is ITS632 class. What is a data mining and why data mining? That is our main objective in our Unit 1, Lecture 1. So first we start with the definition of data mining, and also we try to understand what is a data mining. And here we say data mining is the process of identifying patterns that exist within data. So the whole concept of data mining is try to find a pattern in a large data set. Now with these patterns at hand, data analysis can apply them on other data sets. Now we should think about actual mining as the search for the data patterns. So our main goal is searching for a pattern, or we can use the term knowledge, searching for a knowledge in a data set. So a data mining process may involve the use of, again, statistics, database queries, visualization tools, traditional programming, and machine language algorithm, or machine learning algorithm. So first we should understand what is a machine learning. And the concept of machine learning and data mining, they are almost the same, because data mining uses machine learning algorithm to perform its tasks. But there's a two major difference between them. As we saw the definition, data mining is to try to find a knowledge or a pattern in a data set. But machine learning is more or less action-oriented, or to perform a specific task. So for example, I may use a machine learning algorithm to program a self-driving car, or to program a robot to do a specific task based on the data, the model that we have built. So we can say machine learning is more or less action-oriented. We are using data to perform some specific tasks. While data mining, we are trying to find a lot of knowledge from a data set, and we may apply this knowledge in other problems that we may face. But both of them use almost the same algorithms. So a machine learning is the use of data pattern recognition algorithm, which allow a program to solve problems such as clustering, categorization, predictive analysis, data association, without the need for explicitly step-by-step programming instruction to tell the algorithm how to perform tasks. So here, what we want to see the difference between data mining and machine learning is that they are using the same algorithm, classification, clustering. In machine learning, we use the term supervised learning, which is classification, clustering, unsupervised learning. We also use categorization, association rules, which is data association, in both machine learning and data mining. But as we said earlier, machine learning is more action-oriented to perform a specific task, such as a self-driving vehicle. Whereas data mining, we are trying to find knowledge in a data set, and management can make a decision based on that knowledge, maybe for a prediction. So in this way, we say machine learning solution can solve complex problems by using data to drive discovery in using only a few lines of code. So the whole concept of machine learning is that instead of writing the program to perform a specific task, let's say we are going to write a software program so that application can drive a vehicle, it will be very complex to write that kind of program. So the main objective is to use machine learning algorithm. So in this case, the machine will be, in this case, the software, it will be learned by doing the work. By feeding it more data, it will be learning the patterns. Now, these are some of the common data mining tools. We have the database such as MySQL or MongoDB. These are some databases that can be useful in data mining. Excel also can be used. visualization tools such as Tableau, also business intelligence tools such as Microsoft Power BI can be used by data mining. Programming language solutions such as R, Weka, RapidMan applications, all these can be used. With the common machine learning tools, is the Python and R is the most common, again, tools that are used in machine learning. But visual programming such as Weka, RapidMan, or Orange also can be used. Excel with a third-party hardening such as a solver. Solver is application, third-party hardening to Excel. You can use it to perform some machine learning tasks such as supervised learning or unsupervised learning. We're also going to compare data mining with data science. The main three things that comes to when it comes to data analysis is, again, data mining, machine learning, data science. They are all using almost the same algorithm, but the tasks sometimes are different. So data mining is the process of identifying patterns that exist within data set, as we said earlier. But data science is the use of statistics, programming, scientific methods, machine learning to extract knowledge from data sets. So we can see that data mining and data science are almost similar. But the main difference between now data mining and data science can deal with a very large data set and a very complex, like big data analytics, and uses more complex concepts like distributing programming and concepts, computing concepts. Now, the definition of data mining and data science, as we said, data science, are very similar. And the two sometimes are used interchangeable. So a data scientist, therefore, is an individual who analyzes and also interprets data, while data miner also the same, analyze and interpret data. So you find the term data scientist and data analysis quite similar. And also both use data mining tools to gain insight into one or more data sets. Now, data mining versus statistics. We say data mining, again, is the process of identifying patterns that exist within data. But in terms of statistics, it's a collection, analysis, modeling, and also presentation of data. So statistics can be one of the components of data mining. Because in data mining also, we need to collect data, we need to do our data preparation phase, then analyze the data, and then build a model if we are doing classification. So having knowledge and understanding of statistics normally will make us to understand the concept of even machine learning, data science, data mining. So the main background of this data mining will be statistics and also linear algebra. And the good news is that you don't have to be, again, a statistician to use the tools. We don't need to have a great background in statistics in order to become a data miner. Also, Excel remains one of the most widely used data analytic tools, and it has many built-in statistics functions. Now, why mining data? We look at the commercial viewpoint. We will say the main reason why we do data mining, data science, and machine learning, because there are so many data variables. And we know in this data stored in a data warehouse or database system, we want to see if we can find some knowledge from this data set. Again, we may have a data set about patients that have disease A, or let's say cancer A. Now, we want to find knowledge from this problem, which is the cancer. One, we can go and analyze this data and see what all these patients have in common. Maybe their gene sequence, or their nutrition, or their physical activity, lifestyle contributed to the disease that they have. So this will be the concept of, again, data mining, trying to find some knowledge in the data set. Now, since we have so much data available, we end up trying to find knowledge from this data, and that's the main reason of mining data. So here we say a lot of data is being collected and warehouse. Web data like e-commerce, online shopping, online business transactions. Now purchases at the department store, grocery stores. There are so many data. Doing transaction using your credit card or bank card, we generate data. Even going to make an observation for hotel observation, we generate data. Paying our toll booth, we generate data. Using the internet, other Twitter, Facebook, we still generate data. Using our cell phone every day, communicating, we are generating data. So again, this is the main reason why we mine data. We generate data, and data storage too is becoming very cheap and cheap and cheap, and also very powerful. CPUs are available to, again, process all this data. So computers are becoming cheaper and more powerful. So why mine data in terms of scientific viewpoint? We say remote sensors on a satellite, they are generating data also. When we use the telescope to scan the skies, we are generating data. In terms of computational biology or bioinformatics, we can use microarrays to generate a gene expression data. These are the gene expression is how the gene react to environment. The expression can be stored in a something like a computer chip, and we call this a microarray. Previously, we can only maybe sequence maybe few amount of genes, let's say 200 nucleotides. But today we can do 5,000, 10,000 nucleotides. We implant them in a chip as a microarray and do the studies on it. Yeah, not only in computational, but also in engineering field, we generate so many data. So data mining may help scientists, for example, classifying and segmenting data, or in hypothesis formation also. So mining large data sets, that's our main motivation behind data mining. When we look at the graph here, we can see that how data has been increasing exponentially from 1995 to 2000. So we can see that the total new data is terabytes since 1995. And we can see from the graph how the data is increasing exponentially. So what is data mining? We saw the definition before. The whole concept of data mining is trying to analyzing a large data set and trying to get a knowledge or get a pattern from the data set. So data mining, which can be knowledge discovery from data, is the extraction of interesting, non-trivial, implicit, previously unknown, and potentially useful patterns or knowledge from huge amount of data. And we have so many names for data mining. We may come across some term like knowledge discovery in database, KDD, or knowledge extraction, data or pattern analysis, data archaeology, data dredging, information harvesting, or business intelligence. Again, all these have the same concept of data mining, trying to find a knowledge or a pattern in a large data set. Now, one thing we should watch out is everything a data mining? Of course, no. Sometimes we may do some tags, and these tags can be a query. Example, we have Amazon database system. Amazon want to know which state in US have more customers that purchase items of $1,000. This is not a data mine. I can write a query. That's SQL query. to, again, trying to get the result that I need all customers from each state that spend over 1,000 and count each state for me. This is not, again, data mining. The reason why it's not data mining, always the data mining, we're expecting some result, but we don't know it. In this case, we know the result we are looking for. So it's like we have the hypothesis. We are looking for customers who spend over $1,000, and which state have more customers at that amount. So again, it's not data mining. We also have an expert system that's a deductive concept. So many definitions are available. We saw our first definition of data mining. Another definition here is a non-trivial extraction of implicitly, previously unknown, and potentially useful information from data. Also, the exploration and analysis, either by automatic or semi-automatic means of large quantity of data in order to discover meaningful patterns. Or we can say extracting meaningful patterns or knowledge from a large data set. And this is the process of doing data mining. First, we need data. We can get data from different sources. Then second, we need to select which, again, we can't use all the data. Let's assume we have a population. Population will be everything. If I'm going to do a research, I may not use all the population because of time and also the cost. So the same thing applies to data mining. I may have a large data from different sources, but in the first step, I need to select what data I want to use. After I select the data, which will be like a sample, then I'll do my data pre-processing. This is a process of trying to eliminate errors in the data, duplicates in the data, or trying to replace a missing value with some default value, or find the mean mode to replace the missing values. So data preparations, there are so many techniques to use. For example, we can use the singular value decomposition or principal component analysis. We may discuss all this as time goes on. Then after we do our pre-processing, that's the transformation, where we do the principal component analysis, singular value decomposition, etc. So again, selection, pre-processing with transformation together. Then we move to, now we have a data that is ready for analysis. Now we apply our data mining algorithms, and then we get a knowledge, which will be the pattern. The management can use this pattern to make some decisions. So that's the process again. We have the inputted data. First thing we do is our data pre-processing. So here, data pre-processing, the tasks we can do can be data integration to join two or more data together, or normalization to reduce the large or to increase the minimal value to majority of the values. So we normalize our data. The most common algorithm we use here is the log normalization. Then we do a feature selection. We are not going to use all the data. So we need to select some. It's like taking a sample. Then we do our dimension reduction. This is the transformation phase. Next, we do our data mining. So in data mining, we can do different types of tasks: pattern discovery, association and correlation, classification, clustering, and outline analysis. Then post-processing, after we get our result, again, we interpret the result. Then we have a post-processing. This is where we do the pattern evaluation, pattern selection, pattern interpretation, and also pattern visualization. So what is data mining and what is not data mining? So we have a couple of examples here. What is not data mining? For example, I'm looking up phone numbers in a phone directory. It's not a data mining. Or query a web search engine for information about Amazon. It's not a data mining. But example of a data mining can be Certain names are more prevalent in certain US locations, such as O'Brien or Rocky or Raleigh in Boston area. So this can be a data mining, and I want to know if which part of US we have more last name of O'Brien or O'Reilly. Here we can do cross-storing algorithm. So group together similar documents returned by the search engine according to their context. This can be Amazon Rainforest or Amazon.com. Also, we have a multi-dimensional view of data mining. For example, data that can be mined, data in a database system, such as relational database or extended relational or object-oriented database system. We can also mine data in a data warehouse or transactional data. Most data mining tasks is done on data that has been stored for a long time. So like example with the data warehouse. A transactional data depends on the organization. An organization will say that, okay, every weekend, every Sunday, all the transaction we do for the whole week, we transfer the data to our warehouse. So which means a transactional data will not be more than a week old. But if we go to the data warehouse, it can be over 5-10 years. So it depends when, again, we have the data. So knowledge to be mined, as we said earlier, classification, cross-storing, association, characterization, outline, analysis or anomaly, deviation, again. So all these are different tasks that we can perform. We also have the descriptive versus predictive data mining. We may go details on this. So a descriptive data mining can be association or clustering. We are trying to find similarity within the data. Predictive data mining means we're going to build a model, and based on the model, we can predict future knowledges. Also, the techniques that we can utilize, it can have to be data intensive or data warehouse. OLAP means online analysis process. The knowledge of machine learning, statistics, pattern recognition, visualization, high performance. So data mining again is an interdisciplinary field. Application adapted can be retail, telecommunication, banking industry, computational biology, medicine, stock market analysis, web mining, etc. So here we say data mining on what kinds of data. We can have a data mining, as we said earlier, in a regular database system such as relational database or data warehouse or transactional database. Also, advanced data sets and advanced applications such as data stream can be CCTV, live video, sensor data, time series data. Like I said, the example of a time series data can be the stock market data because this data changes based on the time. Also, structured data, graphs, social networking such as Facebook, Twitter, we can mine all this data. Multi-link data, object relational database, database that deal with space and time. So we have spatial temporal data or spatial data. Multimedia database, text database, and also the World Wide Web. So we can see from this list, we can mine almost any type of data. So again, in these lectures, we discuss about what is data mining and the main reason why we do data mining. So we discuss this too. Our next lectures, we're going to discuss about different types of data mining tasks. Again, thank you for your time and wish everybody the best.